Okay, so today we'll continue with the midship sections. We'll discuss about the container ship midship section, right? Well, what is a container ship basically? As the name, you can see that it carries containers. Containers are somewhat of this type. Somewhat means they are essentially a rectangular container, right? As you can see, it's the dimensions are, they have a cross section of 8 feet by 8 feet and length either 20 or 40 feet, they are in feet, right? This is the universal standard, means all the containers which are used in the container ships, right, they will be either 20 feet long or 40 feet long. One non-standard in between is there, that is 35 feet long, but not a very, I mean, that's not used very commonly or popularly, for the simple reason, here you can see it's a multiple 20 or twice that 40. So, in place of one 40 feet container, I can load two 20 feet container, that is possible, but if I design it for 35 feet, then I have problem. Anyway, so these are the two most widely used. The whole concept of containerization came, as I think so we have already talked about, it's essentially to implement or to have minimum port time. What does that mean? Means very efficient loading as well as unloading of cargo, because a ship owner will not only like to have a very efficient vessel, I mean hydrodynamically designed, so that it consumes minimum power such that your fuel bill is minimum. At the same time, he would like to have systems or facilities such that he can load the required amount of cargo as well as unload it at the minimum possible time, because this process of loading and unloading, they are actually not a revenue earning time for the ship owner. It is actually a expenditure kind of thing for him, because he is in the port, longer he stays in the port, more fees he pays to the port, right? And not only that, he is just kind of idling. Had he been moving, means he is taking the cargo to some destination, he earns revenue, tariff he earns. So, obviously, one would like to have it loaded, unloaded as fast. Now, you have seen the general cargo ship, all cargo are individual, piece of cargo has all kinds of shape and size and weight. So, loading, unloading will be very tedious. Instead, if you can think of a system wherein we pack the cargo in a box of standard size, then the loading and unloading becomes very easy, right. So, that is how the concept of this containerization came. In fact, in container ships essentially are carrying general cargo in the container, right. Instead of piece by piece loading and unloading, I will just handle one container. Whatever items are there inside, they may have different shape, size, weight. So, that is what is the basis of container ship. So, in the process, what happens? This we have seen general cargo carrier or bulk carrier, we have talked about carrying capacity in terms of tons, dead weight, how much dead weight, how much cargo it can carry in terms of tons, 12,000 tons, 60,000 tons, like that. Whereas in container, we talk in terms of TEU, right, 20 equivalent unit. That means, in container ship, the carrying capacity is referred to as in the form of TEU. I have written here 12,000 TEU. What does that mean? That means a vessel can carry 12,000 such containers, 12,000 20 feet long containers, or could be 6,000 40 feet long container, or mixture of that, right. So, this is what is the kind of unit TEU that gives you the idea of how many containers it can carry. So, here while doing the container ship design, you will have to keep in, if the owner wants a 6000 TEU container ship, means you have to make provision, you have to design the vessel in such a fashion that 6000 such containers can be loaded in the ship. And obviously, these containers are not only kept in the hold, also they are kept above the hatch covers. Also they are kept above hatch cover. That of course depends on design, how many tires of container you will keep above hatch cover, means open in the air. It is in any case. So, that is what is container ship. So, what we see, the very typical feature of container ship, what it would be? It would be, as we go on increasing the capacity of container, this 12,000 TEU is not a very common container ship. Commonly we have, well, in the range of, I would say I mean so called ocean going container ship could be in the range of 2000 to, well, maybe 6000, right. This 12,000 and all that is a very ambitious kind of container ship. Possibly one or two have been built. They are huge, they are really huge. By huge, what do you mean? We mean the length could be very, very big, right. So, as the length is becoming bigger, what is happening? It is becoming more slender, your bending moment is increasing terribly, right, and also slender, right. And for, we have talked about, we have containerized the cargo because of easy loading and unloading. So, if we have to do that, we will have to have a midship section, something like a open section, means fully open. Till now all the vessels we have seen, if I just make a comparison here, you can see all the other vessels had a hatch opening like this, right, be it a general cargo carrier or a bulk carrier, right. So, something like this. So, what you see here is that almost half of the deck, approximately, not necessarily, you have the deck plating and then you have a opening. But in comparison to that, if I see a container ship, these are irrespective of capacity. If the general cargo carrier is say a small general cargo carrier, say a 3000 ton general cargo carrier or a 10,000 ton general cargo carrier, you will have sufficient amount of deck plating and then a hatch opening. Similarly with bulk carrier, but a container ship, whether it is a small container ship or a big container ship, its hatch opening would be in comparison like this. If all these three are of the somewhat same so called external dimensions, right, same load carrying capacity, here you can see the hatch opening is much bigger, for the simple reason that unless we do that, we cannot have my loading and unloading so smoothly operated, right, because the containers will be like this, will be vertically loaded and vertically unloaded, one after another it will go, right. So, I will have to have the hatch opening as big as possible, such that I do not waste any space in the side, right, because if I have a small opening like this in case of bulk carrier or general cargo ship, then I have to lower the container and shift it laterally, lower the container, right, and then shift that laterally, which is definitely not a worthwhile proposition, right. So, it is done this way, and this container handling is done fully automated in properly automated ports where you have the facilities of handling container ships. They are automatically done, means without any fully automated system, the containers are lifted and kept on the dock, and from there it is sent to the destination, right. So as the size of the container vessel increases, we have the length increasing, thereby giving rise to increased bending moment. And whether it is a small one or a big one, you have a huge hatch opening, means with increasing length, it's not only becoming more slender and your bending moment is increasing, your torsional strength is decreasing drastically, because it is becoming a case of open section. This is what is a open section. It is somewhat equivalent to a open section, a case of open section. Just the opposite of it is what? Obviously closed section and oil tanker, right? There is a closed section and that is what is the oil tanker. So we can see when those huge super tankers were built. Of course, for some other reason these days those super tankers are no more built. The super tankers means of the carrying capacity of around 500,000 tons of crude. 500,000 tons means 500,000 tons of crude the vessels could carry. Vessel length of the order of 400 meter, huge, right. But today, even making a 12,000 TEU container ship is much smaller than that. But still, we say it's a very challenging business, a challenging job to build a vessel having 12,000 TEU capacity, a container ship, for the simple reason that it's an open section. Torsional strength becomes a big problem here. Well, so that is the basic of it. Now, how this torsional strength is taken care of, that is the major thing here. Till now we have seen, we have designed, well, again the same thing. From the functional requirement, we will have to have a huge hatch opening. From functional requirement, we had wing tanks in bulk carrier. From functional requirement, we had lower deck in general cargo ship, right. Why lower deck? Because for segregation of cargo. In general cargo ship it's called a go anywhere type of ship. So it can carry any cargo to anywhere, any place. It has its own handling facility. It does not need any port facilities. It should have enough draft so that it can park itself. It has its own cranes, derricks to load, unload cargo. And so for segregation of cargo, you provide a lower deck. Certain things you have to unload from there, certain from below, right. Anyway, functional requirement. Wing tanks, functional requirement. Here functional requirement is a big hatch opening, right, a big hatch opening, and that's leading to the other things. There we did not have any structural problem. Here we have a strength problem, torsional strength. That takes precedence. That becomes more important than longitudinal strength. So one will have to look into the aspect of torsional strength, how that has to be taken care of. So here you can see the kind of the deck, well, these are all same, the so called bulwark and your hatch, what do you call, hatch combing, right. So the deck is very small. How small? Well, obviously it has to be enough such that it gives a good walking space, because you'll have to probably walk from the fore end to the aft end, all that. And plus, well, it cannot be just the single skin of the hull, so there will be stiffeners inside, so that much space. So it could be as less as 1.5 to 2 meters even, right. Anyway, so what is done is, this particular arrangement, as you can see at the top, it is called this is primarily, yeah. This full thing taken together, right, it is referred to as box girder. It is something like you have observed the I mean, for domestic use, the tumblers I was talking about. What you see in tumbler, just to give it I mean the necessary torsional strength, right? They are generally of this shape, right? If I keep the edges without any stiffening, it does not have any torsional stiffness. Just to provide stiffening, this is bent like this, isn't it? Those plastic tumblers, domestic tumblers, that gives you the strength. So, here imagine the case, instead of, I mean, we are just simplifying it, trying to draw equivalence, this, and instead of turning outside, say I turn inside, I also have the same stiffness, right? And obviously, here in case of a tumbler, it's a quite a small I mean thing, right? But in this case, it's a long, right, I mean much longer object. So, this rigidity is required all round. So, what is happening? This box girder, I mean this stuff is extending all through, or in other words, like here in the case of the tumbler, just by turning the edge, I could achieve the required stiffness. Now, here obviously stiffness required is much higher. So, I am not only turning the edge, making this heavily constructed. How heavily? What basically is done? If I just enlarge that part of the box girder, it is nothing but this is my maybe we draw it fresh here. Just enlarged section of the box girder. This is the side shell plate, right? Here you have, as usual, your the bulwark and or railing, whatever you have. And then you have this hatch opening here. There is the hatch combing, right? So, only this much is my deck, then rest is full open. So, what is done is, this is your side shell, right? We will just take a look how it is done in other vessels. Say general cargo ship. Once again, you have the deck opening. So, stiffening of this was done by means of a hatch side girder, right? And then stiffening of the deck, you had those deck longitudinals, etc. In case of a bulk carrier, what we did? Stiffening was done by also a vertical plate. I am no more calling it as a girder, but the function is same. Here I had this girder, here I am having the vertical plate with a sloping bulkhead. So, this is providing the necessary stiffness. Now, here what is happening? Bringing that same plate, vertical plate or a girder, and in addition I am having a fully horizontal plate, thereby completing a box like thing, and this is now stiffened. These are my so called deck longitudinals, right. this part of the side shell is also longitudinally stiffened, again for the simple reason that a longitudinally stiffened system gives me best buckling strength. It provides me, I mean it is not only good in case of, I mean it is good in case of structures which is subjected to longitudinal bending, and when a structure is subjected to longitudinal bending, in the event of compression it suffers buckling. So, what is important is buckling strength, right. So, now if longitudinal framing system is adopted, then it will give you a better buckling strength. A better buckling strength means your critical buckling stress will be higher. So, due to longitudinal bending it will not buckle, right, that is what is important. So, here again the same thing, we are providing longitudinal framing system because of the reasons I have just talked about. Thereby this will behave perfectly as far as the longitudinal strength is concerned, and also we have said that if we go for go on increasing the number of container, the length is increasing, bending moment will increase. So, you need more longitudinal strength, right. So, this is how, so this box, the total box, it is referred to as box girder. The word girder means essentially a heavy stiffening member. That girder can be just a T section, right, or girder can be a box like a thing. In this case, it is not only a box, it is a stiffened box. It has all kinds of stiffness inside, right, like we can see. Again, within this box you can see that it is the way it has been done, it has a sufficient strength longitudinally, but again the same issue, these longitudinals are running all along the length, isn't it? So, you will have to have support in between transverses are needed, because while you have the bulkheads, when you have this, whatever that concept of bulkhead, that remains, because one thing you can see, this transverse subdivision bulkheads, they are a must, whatever be the ship type, they are must. Why must? Because that gives us the so called required safety aspect from the safety point of view, that in the event of any accident or damage, this will provide me quite a substantial level of safety before the vessel really sinks, right. So, bulkheads are there. So, in the process what happens, if the bulkheads are there, like here I have drawn in red. So, these longitudinals in the box girder, in that case will be running from one bulkhead to another bulkhead. So, this again becomes quite a huge span, isn't it? So, again from the same logic we will have transverses in between, like we had the deck transverses in the general cargo carrier or bulk carrier, right. So, same logic is there. So, here the transverse means what? Means essentially a plate here, a plate there. So, together it can be one plate which can have a, like in bulk carrier we had the transverse in the top wing tank, same thing, this is a transverse having a flanged, this is drawing a double line, means I am showing that the edge, there is a flat bar welded to the edge which provides, which functions like a face plate. This cross section is nothing but you have the plate and there is a flange welded, a flat bar welded. right. Okay. So, this is a transverse, and now once this is a transverse means, well, those same things, those scallops, those cutouts will be there, right. So, thereby we see that this transverse, so this is a transverse, again the same thing, this transverse will be spaced every 3 to 4 frame space. So, as you can see that entire structural arrangement, whatever be the shape, the method of arranging them, the deployment of stiffening members all follow the same principle, because at the end of the day the purpose is such that there is no part of the structure attains a stress level beyond permissible limit. That is the final purpose. In all service conditions, no part of the structure should attain a stress level beyond permissible limit. Now, only variation of the structural type etc. is coming because of functional requirement. You need here the torsion becomes more important, there the well, the bending becomes more important, and so on and so forth. So, that is how, this is what is the box girder construction. So, this provides me, you can see a quite a heavily stiffened structure right at the top of the I mean at one end of the entire hull structure. So, this provides you a sufficient strength towards torsion as well as longitudinal, obviously as well as longitudinal, but this alone is I mean much less stiffening could have been would have been required if we had have calculated only on the basis of longitudinal bending, right, bending longitudinal strength, but this is provided to provide for additional torsional strength as well as your side shell stiffening. So, you can see the side shell here again is transversely stiffened. You have heavy transverse framing on the side shell, heavy transverse framing on the side shell. So, that your it is maybe this is side shell going, and this is a part of the, well, the transverse frame, which is now which will be suitably bracketed. That red line is the part of the bracket is being shown, the blue line part of the side shell frame is being shown, right, as you can see here.
So,
right.
In this transverse member in the box girder, so we are not having any longitudinals on the bottom side of it.
Yeah, bottom side we have not provided, because you see the construction in the bottom side at every frame space these frames are coming and they are bracketed to the bottom plate. So, bottom plate is stiffened by these brackets. Rightly pointed out that this side plate or the deck plate as well as this side shell plate are stiffened by stiffeners, longitudinal stiffeners, longitudinals, whereas this bottom plate is not stiffened as such. I mean, we are not seeing any stiffener here. What is happening? This is getting stiffened from below by this bracket, because a huge bracket is being welded at every frame position. So, this bottom plate is stiffened by this bracket itself, like these plates are stiffened by these longitudinals, here these are stiffened by these brackets, because this side shell frame, this is a side shell frame, right. This side shell frame will be there at every frame position, isn't it? This is a side shell frame. So, what do you see that the side shell is transversely stiffened. So, transverse stiffening or transverse framing arrangement is taken in the side shell. Why? Had it been longitudinal framing system, then again the case of those too big transverses would have had come, it could have had encroached in the cargo space, boxes would have, I had to shift more, some space, more space would have got wasted. Not only that, in addition to that, for torsional strength requirement, for transverse strength requirement, this transverse framing is better, because here I need, because to provide for torsional strength, I need transverse strength also, because torsional strength is, it gets twisted. Transverse strength, if you do not have, it gets deflected in the transverse plane, right. So, if I provide for transverse strength, it automatically provides for torsional strength. So, side shell is transversely stiffened, and double bottom you can see same as in any other vessel. It will be same as in any other vessel. Only thing here what has to be seen is the frame spacing etc. should be taken in such a fashion that these containers they sit truly on some longitudinal. Like in this, it is not very carefully drawn. As you can see, this corner of I mean this edge of the stack of containers, it is not sitting on a longitudinal. This is not correct. This is not correct. So, depending on the box size, and box sizes are fixed 8 feet by 8 feet. So, their spacing of the, I mean they have self locking arrangement. When you put one box over the other box, one container or other container, they sit properly. That means the container edges, there is a small, actually the container edge is something like this. So, it should sit suppose on the deck, and there should be a stiffener there, right. So, it should be, the arrangement should be done in keeping that in mind, that it should, the load path should be there, proper load path, that means it should sit on some stiffener below. Okay. Anyway, so here we can see that because of this you have the because of the loading, I mean the functional requirement, you need a big opening. For big opening, there is a problem of torsional strength that is solved by this providing a heavy box girder arrangement at the top deck level. Side shell is transversely stiffened, right, with heavy bracketing at both the ends, right, and bottom part, well, a double bottom like in any other vessel. So, with this one can go up to a certain size. Then it was found that when we are talking about 9000 TU, 10,000 TU, bigger and still bigger vessels, then it was suggested to go in for a construction which will provide you the required torsional strength. That means, this kind of box girder arrangement was becoming inadequate, because here your heavy construction is there only at the top. At the middle part or just below that you have, well, transverses are there, but still it was becoming inadequate. So, the idea became that instead of keeping the box only sort of located at the top, that is be continued till the bottom. Let it be continued till the bottom, then automatically your strength becomes much more. Or in other words, you come for a condition which can be referred to as cellular construction or a double wall construction, means double wall, right. This is referred to as cellular cellular construction or double wall construction, not double hull, double wall. So, this is my inner shell, this is my outer shell. Obviously, then it becomes much more stronger, because now what is happening, if we go back to that bucket example, right, instead of this I make the whole thing double. If this way I could have made the bucket wall, then it will become real rigid. Same thing is happening here.
So, sir, we don't have a box cutter here.
The box cutter is not there. The as if the box cutter, that box thing was only this much,
It has extended.
as if it has extended till double bottom. The full thing I have extended. So, in the process, what I have come for? We have come for a cellular construction, a concept of cellular construction or a double wall construction. That means, instead of one side shell, I have two side shells.
So, but this will increase the weight.
This will not only increase weight, it will increase cost, everything it will increase, but it is needed to provide for the required strength, because I have to see, I have to provide for the, I mean, when you are designing a vessel, the purpose is that it should deliver the requirement of the owner. What is the owner's requirement? To transport cargo from one point to another point, that is all, safely. That is important. I am transporting, halfway it gets lost or half the time it gets lost, you cannot do that. You will have to ensure that it will be safely, in a safe and sound manner, it will be transported. Then only people will come and load his cargo in your ship. So, that is what. So, that calls for, as I mean, double wall construction, obviously, as you are saying that, well, it's not only will add to the weight, it will add to cost, isn't it? It's a additional work, additional material, it will add to cost. But this has become necessity as we are growing in size. Probably, if you design a 6000 TEU container ship, you do not go for double wall. It will not be a wise decision. It's that way. But you are building a vessel of 11,000 TEU, probably you will have no other option other than to go for a double wall. One can try through this box and all that, but probably you will find that if I were to do in this, the sizes of the side transverses may become so big. Eventually, the weight of this and cost of this will become more than if we have gone for a double wall, right. So, these are the aspects one will have to see. In any case, in double wall, what is happening? The moment I go for double wall construction, obviously, it is entirely then what? Longitudinally stiffened, because then that problem of your firstly interfering with the cargo space or interfering with I mean cargo or any other functional interference is not there, right. The moment there is no functional interference, obviously I would go for a longitudinal framing system, because that is most effective. So, the entire both the shells, the inner shell and the outer shell, or both the walls are longitudinally stiffened, as well as obviously the deck is also longitudinally stiffened. The whole thing is longitudinally stiffened. And then, as in this case, you had the transverses, right. You need transverses here also for the same reason, because otherwise again the same logic, the longitudinals will have very big span. Now, what is done here is, instead of putting all longitudinals all around, I am cutting off some pair of longitudinals by this green lines. Well, let us take this. Okay. So, these horizontal green lines what I have drawn, they are nothing but platforms. instead of a longitudinal, I extend the full deck as if, one can even imagine as if these are my lower decks in the form of deck. But I am not calling them deck, because it may give you a concept of, okay, deck means, well, usable space. It is not a usable space. This space will not be used for anything, it will remain empty. So, these better I call them platforms. But they are also, these platforms are also strengthening member. Like the deck is a member which contributes towards longitudinal strength, because the deck plating is continuous all along the length. Similarly, these platforms are also continuous, barring the engine room, the entire whole region from the entire length wherever it is there, it is there. Suppose that means, say this is a double walled vessel, then these platforms will continue like this, and in between you have the longitudinals. This is my engine room. So, they are also strength providing members, right. This horizontal platforms also will provide for longitudinal strength, and if they are going to provide me for longitudinal strength, means they will take part in longitudinal bending. So, they are themselves are to be stiffened by stiffeners. So, they are equivalent to that of lower decks, nothing else but lower decks, right. What is the purpose of giving this? This I could have as well avoided and provided this for maintenance. It is simply for maintenance, nothing else, because if this is provided, then a person can walk through all along and do the inspection maintenance of this, because probably it would be something like this. The spacing between these platforms should be such that a person can, an average height person can comfortably walk through. If he can do that, then he can do the other jobs also. Otherwise, imagine how you are going to do the maintenance. So, for that reason these things are provided. So, that means it is a design when you are doing, not only you are taking care of your torsional strength, transverse strength, etc., but also taking care of future maintenance work, right. So, this is what is a double wall construction. Now, we see that it is perfectly done as far as longitudinal strength is concerned, and to provide for necessary or required transverse strength, and also providing for supports to the longitudinals, you have now similar type of transverses. Right. I can have transverse members like this, like the one here. It is as if that this plating was there. So, a number of boxes I have added. This double wall, you can see the way I have drawn it. As I said, that box thing I have extended. So, I can do it in this fashion, right. So, it is not necessarily that this is the only way of designing it, but very concept, I mean the idea is that you design, you do the structural layout, there can be different solutions, different way of doing it, but you will have to keep in mind, well, the strength part of it, fabrication part of it, maintenance part of it, so that the arrangement it is friendly from the production point of view. Arrangement, it gives you the requisite strength. Arrangement gives you the it becomes maintenance friendly also. So, this is one of the very simple way of doing it, right. And so, it provides for all necessary, I mean this satisfies all those necessary conditions of strength, production friendliness, maintenance friendliness, right. So, this is what is the double wall construction. And now below this again same thing, means the double bottom, there is no difference in the double bottom. Well, only thing could be that one can decide upon a center girder or one can decide upon a duct keel. That is up to the I mean both are same, but well, you have some functional advantage in a duct keel. So, you can have a duct keel arrangement or a center girder arrangement, that depends on the designer. So, this is what is a cellular or double wall construction, which provides for necessary required torsional strength. And here another advantage you can see, you have the cargo space, the so called container loading space is absolutely clear of any obstruction, because you have a horizontal flat clean bottom, you have a vertical flat clean wall. So, there is absolutely perfect rectangular space or cubic space is available, wherein you can I mean these containers can be properly loaded. So, that is what is your what is called container ship. And well, so the midship section for a double wall will look like this, and well, this is your hatch cover. So, on the hatch combing you have the hatch covers, and over what is done is you have those big hatch covers. So, over the hatch cover also containers are stacked, right. So, in this process what happens, that a very typical feature of container ship is that you may have an additional superstructure in the forward. These are my containers stacked on the hatch covers outside the hold. You have required number in the hold, and you have provision for keeping, as I have drawn, 3 more tiers of containers above the hatch cover. Accordingly, the hatch cover has to be designed, obviously. That means this should be able to take that load, right. Well, and generally you have your so called superstructure or the deck house just above the engine room. Why it is located above engine room? What could be the reason? Simple, access to the engine room, because in that deck house or superstructure, who will stay? It's basically the engineers and the deck people, deck officers, right. Well, deck officers may not have any business in the engine room, so they could have been elsewhere also, right. But you generally in a ship you have only one superstructure, one deck house where engineers and officers all are housed. Primarily it is built there. Why? Because from there right directly you have access to the engine room. Instead of coming out, you just straight away go down. So, that is good. Now, in case of container ships, generally you have 2 sets of superstructure, like I have drawn that one in the forward, one in the aft. Can you tell me why? I mean, just from common sense. Generally, you will find two sets of superstructure. Because you have here this container stacked, right. So what happens? Yes. No problem. Thing is, from the wheelhouse deck, your line of sight, your visibility should be there, perfect. So, here that gets affected, isn't it? If there are containers, like, anyway, let us draw a small one. Suppose say for example, this is my wheelhouse, and you have containers stacked like this, right. So, then what is happening, your visibility, your line of sight is becoming like this, your water level is somewhere here. So, you can see it is going much beyond. So, this place is becoming the blind zone. There is a rule that blind zone cannot be more than some length of the ship. I think 1.5 length of the ship or some such rule is there. It cannot be more. In such an arrangement, your blind zone will become several times the length of the ship. So, anything coming in front of your ship you do not see, that zone becomes too long. So, that is solved by providing a forward superstructure. So, then you have a very easy, I mean very small so called blind zone, only this much, right. And well, very nicely you can house all the deck officers in the forward superstructure and the engineers in the aft superstructures. So, no problem, right. So, that is a typical feature of a container ship. It may have 2 deck houses for this reason. Otherwise, this particular deck house will have to be made several tiers higher and too high, which is not very feasible. Well, so that is what is about the container ship. So, in we can see that here, if it is a box girder kind of arrangement, then we take a combination of longitudinal framing system and transverse framing system. If it is a double wall construction, then all along longitudinal framing system, there is no transverse framing system taken, right. Okay. So, we stop here today.